Okay, let's move into a new topic, a new lecture, but it's not as new as we think. Why? Because it's a continuation of differentiation techniques. Part 2. Now, in this particular section, we're going to work with 2 more theorems, and I'm giving them to you right up front. That way all we can focus on is examples in a little bit. So the first theorem is known as the product rule. And if I'm trying to find the derivative of a function, and the function is made up of multiplying 2 other functions together, then here's how I find the derivative. To find the derivative of that function, I'm going to take the derivative of the first function, multiplied by the second, add to it the first one multiplied by the derivative of the second. There's only 2 places you take a derivative. Here's the first function and the second function. Now I'm going to be honest with you. With this product rule, you could actually take these 2 sides and flip them around, so to speak. I could actually do this one first, this one second, and add them together. But there's a reason I'm doing it this way, because it's going to help us with this second theorem. So again, the product rule says, take the derivative of the first function, multiplied by the second, adding, here's the first one, multiplied by the derivative of the second one. Good? Okay. The reason I did it in that order is because when we go with the quotient rule, the quotient means we're working with a division problem, which means I've got the numerator divided by the denominator. Clearly the denominator can't equal 0, right? Okay. Now, to find the derivative of this quotient, you're going to take the derivative of the first one, which is the numerator, multiplied by the denominator, and now I'm subtracting. And it matters the order in which I subtract, doesn't it? It doesn't matter the order in which I add, which is why this one can be written in the opposite direction. But it matters the order in which you subtract. The numerator times the derivative of the denominator all over the denominator squared. Okay, now this is just the denominator squared. It's not the derivative of it. It's just the original denominator squared. So take a few moments, write down these 2 theorems, and I'll be back with a couple examples. Well, probably more than a couple. Okay, so let's look at this problem. They're asking me to take the derivative of this function. Now notice, this function is made up of multiplying 2 other functions together. Now if I really wanted to, I could do the distribution on this and then take the derivative using the power rule. Well, that might not be so bad if I didn't have a square root in there. So I think it just might be easier for us to use the product rule. So just watch and then rewind this and then write stuff down, okay? But just watch for now. Make sure you understand how I'm approaching this. To find the derivative of this function, I need to take the derivative of the first one, multiply it by the second one, add to it the first one, multiply to it the derivative of the second one. That's the product rule. This is how I find the derivative of a product. This is the product rule. Good? Okay. So here we go. Right? So take it slow. To find the derivative of this whole function, I got to take the derivative of this one first. So am I expecting you know the product rule? Oh yeah, very well, as a matter of fact. Because I'm going to bring this 2 down, and I'm going to do 2 times 3, which gives me what? Yeah, 6x. Plus, what's the derivative of 4x? Just a 4. Right? And if you need a refresher, go back to the previous lecture on differentiation techniques part 1. All right. Now, this second one here, I'm not taking the derivative of it. So I'm just going to write it down. Now, I'm going to be honest with you. I am going to rewrite the square root of x as x to the power of, that's right, 1/2. Good? Okay. Add to it. Oh my. Some of you caught it and you're trying to tell me and I didn't catch it till just now. This was a negative, wasn't it? I forgot to write the negative there, which means this is a negative 6x, isn't it? Boy, one minus sign will throw the whole thing off, won't it? Oy. Okay. Plus, I'm not doing anything with the first one, so I'm just going to rewrite it. And now I need to take the derivative of that second one, don't I? Okay, so this is really 7x to the 1/2 plus 1, isn't it? And this is what I'm taking the derivative of. Agreed? All right, so see if you follow along. The 1/2 comes down. So I got 7 over 2 x to the negative 1/2 plus 0. Right? Okay. So far, so good. We're in agreement. Let's see what the next line looks like then. And now we have a distribution to do. So, negative 6x times the 7x to the 1/2. Good. You get negative 42x. So this is the power of 1. This is the power of 1/2. What do you do when you multiply these x's? Yeah, you add the exponents, which is why that's a 3/2, isn't it? Minus 6x, because I times it by the 1, plus 28x to the 1/2, and plus 4. Agreed? Okay, let's see what happens on this second part. So this looks like negative 21 over 2 x to the 2 plus a negative 1/2, right? Yeah, that's a 3 over 2 plus, yeah, that's going to be 28 over 2. I know it reduces, hang in there. X to the 1/2 power, right? Okay. And just checking some work, making sure that what I did before is agreeing with what we're doing now. Dun, 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 dun. Okay. So, yes, we're good. Let's keep on going. And now I get to combine like terms. All right, so let's find out some like terms here. I got these x to the 3/2 powers, don't I? Okay, so I've got a negative 42 x to the 3/2, and I have minus 21 over 2 x to the 3/2. Okay, common denominator. Go add them. I'll be back to you. Go ahead. What'd you get? Negative 105 over 2 x to the 3/2. Good? All right. And then I've got this negative 6x, which I don't see any other x's, do you? And then I've got this x to the 1/2. So what is that? 28x to the 1/2. And this is a 14, isn't it? X to the 1/2. Okay, what do we get? Good. 42x to the 1/2. And lastly, it looks like a plus 4 here. Can't add anything else. So are we done? We're done. Now here's my recommendation, because I said don't write anything, just watch. My recommendation is rewind this problem, go back and work it out with me and make sure you understand what we did. So when you write it in your notes, you're like, oh, I get it now. Cool? Okay, stay tuned. I got another problem. All right, let's look at this next problem. Still taking the derivative, but now I'm given a quotient, right? Okay, so let's find the derivative of y with respect to x. Now, the quotient rule is very similar to the product rule. I didn't say exactly the same, I said similar. The first thing we're supposed to do is take the derivative of the first one, which in this case is the numerator. We're supposed to multiply it by the second one, which is the denominator. And now we're supposed to subtract, right? There's one change from the product rule. And then I take the numerator, or the first one, right? I don't do anything with it. And I multiply it by the derivative of the second one, which is our denominator. And then here's another major change. This is all divided by the denominator squared. Cool? Okay, again, don't write, just watch. Let's see what happens here, because then you can always go back and rewind it and see what we've done. So I've got to take the derivative of the first one, which was the numerator. So again, it's the power rule. So I'm expecting you know your power rule very well. And if you need to, go back to the differentiation technique part 1 and refresh your brain. So this would be 12x to the third, because 4 times the 3, right? Plus 2. And I'm multiplying it by x cubed minus 1, and now I'm subtracting 3x to the fourth plus 2x, and I need to take the derivative of this one, which is just 3x to the power of 2. And then the whole thing is divided by the denominator squared. Good? Okay. So, we've got some distribution to do, don't we? So 12x cubed times x cubed. Good, 12x to the power of 6 minus 12x to the power of 3 plus 2x to the power of 3 minus 2, right? Minus. This distribution looks like 9x to the power of 6 plus 6x to the power of 3 all over your denominator squared. Are you with me? Okay. From here down is all algebra, and you've got to be careful of your distribution and your distributing of that minus sign. So I'm going to be collecting some like terms first. So on this first bracket, I'm noticing I have a 12x to the 6th minus 10x cubed minus 2. And I don't need those parentheses. Why? Because there's nothing in front of this bracket that I have to distribute, so I'm not worried about it. And then here I'm distributing the minus sign. So that's a minus 9x to the 6th minus 6x cubed all over this denominator squared. Yes? Okay. Let's see then the derivative of y with respect to x. 12x to the 6th minus 9x to the 6th, right? So I get 3x to the power of 6. So that takes care of that one and that one. Negative 10x cubed, negative 6x cubed gives me a negative 16x cubed. That one and that one. And then a minus 2. All over the denominator squared. And I know some of you are going, are you going to multiply that denominator squared? No, I'm leaving that just denominator squared. And not much else I can do with that. I mean, I could try to factor the numerator and see if I could cancel anything out of the denominator. But in this case, that's really not going to happen. So this would be my final answer. This is the derivative of this problem. Good? Okay, so rewind this section. Go back, start doing the work with me and see if you agree. All right? And then move on to the next problem. I'll be right back. Okay, so before we move into this third problem, there's something I'd like you to notice about the first two problems that we did. You know, one was a multiplication problem, one was a division problem. And based upon the theorems that we spoke about at the beginning of this lecture, the theorems actually told me how to handle the derivative of a product and a quotient. But when I'm taking the derivatives in the product or the derivatives in the quotient, I'm still using the power rule. Understand that. I'm still using the power rule. The quotient and the product theorems tell me the order in which to take the derivatives and how to work with them, add them together, subtract them, multiply them by whatever. But they tell me the order in which to take the derivatives. The derivatives are still being taken by using the power rule. Understand that. The power rule is the base of taking derivatives. Good? Okay, so let's look at this third one. Again, this third one happens to be a quotient. So, don't write, just watch. Okay? Or if you're like, no, I want to try it, then try it along with me. Okay? Or pause the video and work on it a little bit and then start the video, right? And let me catch up to you and see if we agree, and you know where I'm going with that. All right, so first things first. To take the derivative of this function, since it is a quotient, I'm going to take the derivative of the numerator, and I'm taking it with respect to t, because that's the variable in there. So take the derivative of the numerator, multiply it by the denominator, subtract the numerator, multiply it by the derivative of the denominator with respect to t, and then this whole thing is divided by the denominator to the power of 2. And just like the last one, I am not squaring that denominator out. I am leaving it alone. With me? Okay. So, the derivative of this function. The derivative of this with respect to t. See if you follow along. That would be 6t to the power of 1 plus 2. Multiplying it by the denominator, subtracting the numerator, multiplied by the derivative of the denominator, which is, see if you follow along, negative 2t plus 4. And then the whole thing is divided by that denominator squared. How are we doing? Are you guys agreeing with me? Are you getting the same thing I am? Good. Love it. All right. At this point, it's algebra. I got to make sure I distribute correctly, not only the polynomials, but that minus sign later, yada, 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 right? Okay, so the derivative of this function is going to look like, what is that? Negative 6t to the power of 3 plus 24t to the power of 2 plus 6t minus 2t to the power of 2 plus 8t plus 2. And then I'm subtracting, what is that? Negative 6t to the third, right? And then 12t squared. And then negative 4t, right? And then plus 8. Oh, pardon me. Negative 4t squared, right? Woof! Good thing you're doing it with me. And then 8t. And then a positive 2t. And then a minus 4. And the whole thing over. You know, I'm not going to write the denominator squared for just a moment. Why? Because this numerator needs a lot of help. So bear with me. Understand that denominator squared is going to come back. Got it? All right, so I just want to work on the numerator for now. So let's see. Let's combine some like terms in these parentheses. So what do we got? Negative t cubed. And there's a 24t squared and a negative 24t squared, right? So that's a 22t squared. And that looks like a 14t and a plus 2. Are you in agreement with me on that? All right, let's look at the second parenthesis. That's the only t cubed, isn't it? Negative 6t cubed. And that looks like what? A positive 8t squared. And that looks like a positive 10t. And then a minus 4. Good? Like I said, from this point down is algebra, and we just have to be careful of our algebra. Now, this minus sign gets distributed. Agreed? So I'm going to distribute it here. So this becomes a positive 6t cubed. This becomes a negative 8t squared. And a negative 10t and a positive 4. All right? So, let's get the final. So a negative 6t cubed, but then a positive 6t cubed. It looks like these two guys are going to cancel. See ya! And then a 22t squared and minus 8t squared. That looks like a 14t squared. And then a 14t minus 10t. That looks like a positive 4t. And then a positive 2 and a positive 4 looks like a positive 6 all over the denominator squared. Woof! That was a lot of algebra. But we got it! So yay! Again, go back and rewind this problem. Work it out with me. Or work it out for your, pause the video, work it out for yourself ahead, right? Start my video, let me catch up to you, pause it, keep working, start it up again, you know where I'm going. Got it? Okay. Time to go find a tangent line. Okay, we're back with finding the equation of a tangent line. I'm telling you right now, this problem never goes away, so just get used to it. And again, how do I find the equation of a line? I need the slope, and I need a point. Well, gratefully they gave me a point, so what do I need? I need the slope. So how do I find the slope of a tangent line? That's right, you got to take the derivative of that thing. Woohoo! Ready? Okay, here we go. So what did we say we got to do first? Find the derivative. So first, find slope by, I didn't write f, did I? Nope. By first finding the derivative of y with respect to x. Okay, so let's see what you got from the last two problems in finding the derivative of a quotient. I am going to take the derivative with respect to x of the 4x. I am going to multiply it by 1 plus x squared. Subtract 4x times the derivative of 1 plus x squared. The whole thing over 1 plus x squared squared. Right? Okay. So I need the derivative of 4x. What is that? Good, just 4. I'm going to multiply it by the 1 plus x squared. And then I'm taking this 4x and I'm multiplying it by the derivative of 1x squared, which is 2x. Good job. All over the denominator squared. All right. Again, the algebra is what we have to be careful of. So when I do my distribution, looks like I got 4 plus 4x squared minus 8x squared over that denominator squared. And I'm going to bring this up here. It looks like my generic slope, the derivative of y with respect to x, is going to equal 4 minus 4x squared all over the denominator squared. Agreed? Okay, but that's the generic slope. How do I find the specific slope for this problem? Good. You got to plug in the x, don't you? So I am going to switch this a little bit. Well, the derivative of y with respect to x evaluated at x equals -1, right? All right, so let's see what happens. 4 minus 4 times -1 squared. 1 plus -1 squared, the whole denominator squared. So what do we get? 4 minus, yeah, -1 squared is still a positive 1. So 4 times positive 1 is still a 4, isn't it? Well, I feel like I don't even have to deal with the denominator, because what am I getting for this derivative? Yeah, I'm getting a 0, which means my slope, right? I don't really care what this thing is squared. This is going to equal 0, which means my slope is 0 in this case, isn't it? So be it. My slope is 0. My point is -1, -2, right? Which means when I look at the point slope formula and plug in my numbers, I get y minus a -2 equals 0 times the quantity x minus a -1. Well, this is y plus 2 just equals 0, right? Because 0 times a parenthesis is 0. So it looks like my tangent line is just y equals -2. So at this point, for this graph, the equation of your tangent line is y equals -2. It's a horizontal line. Good? Okay. Again, if you need to, rewind this problem. Finding the slope is, for these tangent lines, that's actually the most amount of work, is finding that derivative. Got it? Okay. I got a couple more applications, so